Hello students, welcome to Distinction Learning Platform. In this video, we'll be talking about covalent bonding and what we call chemical bonding. But before we begin our lessons, don't forget to subscribe, like the video, as well as comment in the comment section. Alright, now let us begin. So, before we go to covalent bonding, let us try to remind ourselves about chemical bonding. What is chemical bonding? So, chemical bonding, we said, it is just the chemical combination of different atoms in order to form what we call a compound. Again, did we say about chemical bonding? We said chemical bonding is just a chemical combination of atoms in order to form what we call compounds. Okay? If you want to know more about this chemical bonding, basically just go and watch the video about the introduction about chemical bonding. Alright, now let us proceed to talking about covalent bonding. What is covalent bonding? Covalent bonding, basically, this is a type of bonding that exists among nonmetals. So let us write what we are saying. We are saying that covalent bonding is a type of bonding that exists among non-metals. Okay, so meaning that for you to identify that this is covalent bonding, basically we need to identify the atoms that are combined with one another. Let me give you an example. If I get carbon and I react with oxygen, basically I know that I'm going to have what we call carbon dioxide. Okay, this type of bonding is what we call covalent bonding. Why? Because in these two nonmetals, which is carbon is a nonmetal, oxygen is a nonmetal, and we are producing this molecule. And this is what we call covalent bonding because it is existing among nonmetals. Alright? We need to understand on that. Another thing that we need to understand about covalent bonding is that it involves what? It involves sharing of electrons. Okay, this one is going to involve sharing of electrons. If you try to remember or try to compare with ionic bonding, remember that ionic bonding involved the transferring of electrons from a metal atom to a non-metal atom. That's what we talked about the ionic bonding. Now, in covalent bonding, basically it's just the opposite. Two atoms, they are going to be sharing electrons in order for them to be stable. We need to remember on that, all right? So those are the things that we need to remember. Now, for us to fully understand about this covalent bonding, we need to look at a good example talking about covalent bonding. Okay, so this is example number 1. Okay, so this is the first example. Example 1. Okay, and the question reads, okay, using dots and cross symbols, okay, show the chemical bonding, okay, between which is nitrogen and hydrogen. Okay, this is the first good example that we're going to look at. Okay, first example is saying using dots and cross symbols show the chemical bonding between nitrogen and hydrogen. Okay, now you need to be following the steps that are involved in molecular bonding for you to fully understand the whole concept about molecular bonding or covalent bonding. Okay, so now let us look at the things that we've been given here. What are the things that we've been given? They are telling us to use the dots and cross symbols. Okay, so we're going to be using the dots and the cross symbols for us to show the bonding. All right, and this bonding has to exist between what? Nitrogen and hydrogen. So we need to look at the first step. what is the first step if you are given a question under molecular bonding or covalent bonding? Make sure that you write the chemical formula. So what is the first step? The first step is what? Make sure that you have the chemical formula between two atoms, okay, or three atoms. So we're saying the first thing is make sure that you have chemical formula. Okay, chemical formula. So that's the first step. So mean that we are going to make sure that we have that chemical formula between those atoms that are what? Reacting. Okay, so we have nitrogen and hydrogen. These are the atoms that are what? Reacting. So what are the two atoms that are reacting from this? Nitrogen and what? Hydrogen. So I'm going to say nitrogen is reacting with what? Hydrogen. So make sure that nitrogen is on the first. Why? Because it is preferred here and compared to hydrogen. So these are the two reactions that are, these are the two atoms that are reacting with one another. Then the next step that we need to understand here is we need to put what? The valence numbers here. Okay, we need to put the valence number for nitrogen and the valence number for hydrogen. But how are we going to do that? If you look at the nitrogen, so let us start with nitrogen. Nitrogen on the periodic table, it has the mass number of 14 and the atomic number of 7. Okay, we always follow the bottom number here, which is the atomic number or the electron number. We follow that one. Okay, so I'm going to follow this one so that we write the electronic configuration. Why doing so? Because we need to know the group number of nitrogen as well as the valence number of what? Nitrogen. If you look at this 7, we're going to say in the first shell we always write 2 out of 7. So out of 7 we've only written 2. Then out of 7 we're going to have 5. Okay, then this 5 in the second shell we need to write about 8 electrons. Now this 5 that I've left with is less than 8, meaning that I can just write 5 here. So to verify your answer, make sure that you add 2 plus 5, it has to give you the atomic number, which is 7. Alright? So this is the electronic configuration of what? Nitrogen. Okay? And if you look at in the last shell there, in the last shell here, there are 5 what? Electrons. There are 5 electrons indicating that nitrogen is in what? Group 5. So here in the last shell, it has 5 electrons, and since it has 5 electrons in the last shell, indicating that nitrogen is in group 5. If you do this now, since it is in group 5, we know that for you to find the valence number for group C more than 4, we said from 5 to 8 groups, we know that the formula is we need to have 8 minus the group number. Okay, that's the formula for you to know the valence number for each atom or element that exists in group 5 up to group 8. Simply just get 8 minus group number. So what we're going to do here is we're going to say 8 minus, since we are looking for nitrogen, nitrogen is in group 5, we're going to put 5 here, and the valence number for nitrogen is going to be nothing but equal to 3. Okay, and that 3 is the one that I'm going to put here because it's going to help me to formulate the chemical formula for this compound that we're going to produce here. Okay, now if you look at hydrogen, since we're done with the nitrogen, let's go to hydrogen. Hydrogen on the periodic table, it has the mass number of 1 and the atomic number of what? 1. And nitrogen, this one is just going to have 1 electron in its outermost shell, meaning that it is in group 1. Hydrogen is in group 1, and remember that the rule for the valence electrons, the rule is like this: from 1 to 4, from group 1 to group 4, meaning that the group number is the valence number. If an element is in group 2, meaning that the valence number will be 2. If an element is in group 3, the valence number will be 3. If an element is in group 4, the valence number will be 4. If an element is in group 1, the valence number will be what? 1. So it simply means that an element in group 1 to 4 is equals to the valence number. So if hydrogen is in group 1, meaning that the valence number of hydrogen is 1. So I'm going to put 1 here. Then after you do that, we are going to cross multiply. So I'm going to cross multiply 1 times nitrogen, you're going to say 1, which is nitrogen. 3 times hydrogen, you're going to say H3. Okay, and this compound is what we call ammonia. Okay, that is the name for this compound. Okay, that is ammonia. So that's the first step. So if you are given a question like this, make sure that you write the chemical formula, because the one that's going to show or help you to what? To write the bonding between these atoms. Okay, after you do this, what is the second step now? So the second step now is this one. Now we need to show the bonding between two atoms using what? Using this electronic configuration. Now there is another important concept that you need to understand. So under molecular bonding, it is advised to write the last shell. So again, under molecular bonding, it is advised to write what? Only the last shell. But if you remember, under ionic bonding, it is advised to write starting from the first shell up to the last shell. It is advised to do that. But molecular bonding or covalent bonding, we only write the last shell. All right. So now here the second step. The second step is now to show the atomic structure. So we are showing now atomic structures. So we are now showing the atomic structures. Now we need to just include the last shell. Okay, that's the last shell that we're going to show. That's the second step. Now, this atomic structure, the question that you can ask is that, how am I going to write this atomic structure? Now, for you to differentiate, because from the question here, we haven't specified the type of bonding, but how are we going to know that we're talking about covalent bonding? Is this one, because remember that a covalent bonding exists among what? Non-metals. Nitrogen is a non-metal, hydrogen is a non-metal. Definitely, it will tell you that what we're talking about is covalent bonding. Okay? So remember that under covalent bonding, we said involves sharing of electrons. Okay? Sharing of electrons. So we're going to make sure that we're going to be sharing electrons. So if you look at here, if you look at nitrogen and hydrogen, we need to understand that which one is going to surround one another. Okay, which one is going to surround the other atom. Okay, so if you look at nitrogen, okay, nitrogen, it has the lowest number here. If you look at nitrogen here, it has here 1. Okay, even if we don't write 1, but nitrogen has 1, hydrogen has 3. So the one with the lowest number is the one that's going to be on the center here. Okay, so this is nitrogen on the center. Why? Because it has the lowest number. Okay, if you look at now hydrogen, hydrogen is the one that's going to surround this hydrogen. If you look at it, okay, these are what? Hydrogen atoms. Why? Because if you look at hydrogen, how many hydrogen are here? They're about, now they need to be about 3 hydrogen, and this is what? Nitrogen. If you look at that, okay, this is how you can write the last shell of these atomic structures. As you can see, we are sharing, because this one is the hydrogen atoms are surrounding what? Nitrogen, mean that they are sharing, involving sharing according to the what? Characteristics that we talked about earlier on. Okay, so this is how you can do it. All right, now if you do this, this is simple to do. Now the other important step that you need to understand is this one. Make sure that you listen carefully. Okay, so we need to understand something here. If you remember, if you get nitrogen, so we need to understand now something here. This is nitrogen. Remember that nitrogen, we're only following 7, which is the atomic number. And what is the electron configuration for nitrogen? Nitrogen, the electron configuration is 2, 5. This is the electron configuration for nitrogen. Then another one that is for what? Hydrogen. Hydrogen is what? Just 1. Okay, right, like that. So electronic configuration is going to help you when it comes to molecular bonding or covalent bonding. Okay, make sure that you understand that. Now, if you write something like this, then ask yourself, this is nitrogen, and we're only following the last cell. So this is the last cell. Okay, that is the last cell where there are 5 electrons, and this is the last cell for nitrogen. Okay, and this one is the last cell for hydrogen. We only follow the last shell. So these two, which is in the first shell, which is not important under molecular bonding. Now ask yourself, for an atom to be stable, if it has two shells like this, it has to obtain about what? 8. Remember that, if you remember the rule, we know that in the first shell, for an atom to be stable, it has to obtain about what? 2 electrons. In the second shell, it has to obtain about 8 electrons. In the third shell, 8 electrons. In the fourth shell, 8 electrons. Then if you see something like this, an atom is stable. So we need to make sure that nitrogen obtains this type of configuration or electronic configuration, meaning that we need to make sure that this 5 becomes what? 8, because it is in the second shell. Okay, so for 5 to become 8, how many electrons are we supposed to add here? So we need to add about what? 3 electrons here, because 3 plus 5 is going to equal to what? 8, so that the nitrogen becomes stable. Okay, then what about hydrogen? Hydrogen, for it to be stable, now it has just 1 electron, so meaning that this is the first shell. Okay, because this is the, if there is just 1 electron here, and it's going to indicate you that this is the first shell, and the first shell has to obtain about what? 2 electrons for that atom to be stable. So for hydrogen to be stable, it only requires what? 1 electron. Why 1 electron? Why? Because 1 plus 1 is going to equal to what? 2. So what we're simply doing here is to make sure that each atom becomes stable. That is the goal of an atom undergoing what we call chemical bonding, because it has to make sure that it is stable as a result. Now, this is the thing. After you do this, now the next thing that we need to do here is, what are these 3 electrons? Because 5 electrons are for nitrogen in the last shell. Now, where are these 3 electrons coming from? So these 3 electrons are coming from what? Hydrogen. So hydrogen is going to donate about 3 electrons. Okay, so this is the thing. You come here, this is hydrogen, this is hydrogen, and this is hydrogen. For nitrogen to be stable, it needs about what? 3 electrons, and these 3 electrons are coming from what? Hydrogen. So this hydrogen, and this is hydrogen, this is for hydrogen. Hydrogen is donating what? About what? 3 electrons. So this, each hydrogen is going to donate 1. Why? Because hydrogen only have what? As what? 1 electron. So each hydrogen is going to give 1 electron to what? Nitrogen. Also, this hydrogen is going to give what? 1 electron. This hydrogen is going to give what? 1 electron to what? This nitrogen. So that if you look at the number, nitrogen needs about what? 3 electrons coming from hydrogen. How many electrons are here? 1, 2, 3. So these are the 3 electrons required by nitrogen for it to be what? Stable. All right. Again, nitrogen, for it to be stable, requires about what? 3 electrons. But these 3 electrons are coming from where? Hydrogen. Okay. This hydrogen, now they're going to be giving out what? Each hydrogen is going to be giving out 1 electron. Why? Because hydrogen, each hydrogen contains only 1 electron. So 1 hydrogen, 1 electron, the other one, and the other one. So that 3 electrons are going to be given to this nitrogen for it to be stable. Now also hydrogen needs 1 electron for it to be stable. But this 1 electron will be coming from what? This nitrogen. So that now this hydrogen becomes stable. So again, I'm going to use red. Now since I've used the cross symbol here, I'm going to use now for nitrogen in red, I'm going to use what? Now the dot symbol. Okay, so nitrogen, now this hydrogen, for it to be stable, I need to give about 1 electron, because if I give 1 electron to this hydrogen becomes stable. What about this one? Hydrogen. Also, I'm going to give what? 1 electron for it to be stable. What about this nitrogen? Nitrogen is going to give what? 1 electron to this hydrogen for it to be stable. Okay, that is the second step. So make sure that you understand this. If you understand this one, also this will be very simple. Okay. Now, after you do this, you are not yet done. After you do this, ask yourself the last question now. Okay, since I'm done with the bonding, now what is the other thing that I need to do? The other thing that you need to do here is we need to start with nitrogen. if you come to nitrogen, ask yourself, in the last shell here, I need to have about what? 5 electrons for what? Nitrogen in the last shell. Okay, but out of 5, I've used about what? How many? 1, 2, 3. So out of 5, I've used 3 electrons to give out what? To hydrogen. Then the remaining out of 5, I've used 3. The remaining electrons are what? 2 electrons. So out of 5, I've only used 3 electrons, but the other 2 electrons, they are not part of what? Bonding. I'm just going to put them outside so that I confirm my answer. So now, for you to be very, very much sure about what you are doing is that you need to count the electrons for nitrogen. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. This is for nitrogen, and this is the last shell for nitrogen, equating to 5. All right, then you go to hydrogen. Hydrogen, ask yourself, okay, how many electrons are in hydrogen? We know that in hydrogen there is just 1 electron. Okay, now out of these 1 electron for hydrogen, have I used all the electrons for hydrogen? So that maybe if I didn't use all the electrons for hydrogen, I can put outside here. Now if you look at the hydrogen, I used 1 electron. So meaning that I used 1 electron, meaning that the electrons that are going to be remain there is 0 because I've used the electron for hydrogen. Okay, so I've used 1 electron for hydrogen, meaning that nothing I'm going to put outside the hydrogen here. Also for this one, I've used this 1 electron, meaning that nothing is going to be left so that I can put it outside here. Then if you look at this one, also the same thing, I'm not going to put anything outside. Okay, so that should be your last step. Your last step is to make sure that you put electrons outside the bonding. Okay, outside where, like I've added for nitrogen 2 electrons. Now the last thing that you need to do after you do all these steps that I've talked about, make sure that you do something here. Then what you need to do here is nitrogen. Remember what we said. Nitrogen, for it to be stable, it has to have about what? 8 electrons. You need to check your answer. Okay, for it to be stable, it has to contain what? 8 electrons. If you remember, 5 plus 3, it has to contain 8. What about hydrogen? It has to contain what? 2 electrons. Now you start counting. Okay, you start counting. This circle, everything within the circle for nitrogen is for nitrogen. If I was to count everything now here, the all electrons in nitrogen, 1, 2, 3, 4, 5. Okay, then what about the other one? 5, 6, 7, 8. So for nitrogen now, the total of electrons for nitrogen is what? 8. Now I know that the answer that I've added here is correct. Why? Because the total number of electrons within nitrogen atom equals to what? 8, meaning that it is stable. What about hydrogen? Hydrogen, you go to the circle for hydrogen. This is the circle for hydrogen. You count how many? This is 1, 2. For hydrogen, it is stable 2. What about this one? 1, 2. This is the circle within hydrogen. 1, 2. What about this one? 1, 2. Mean that you are correct with your answer. So make sure that you follow the steps that I've talked about. Okay. Now let us look at the last question. Let us look at the last question. Using dot and cross symbols, show the chemical bonding between carbon and what? Oxygen. Carbon and oxygen. What is the first step? The first step is to make sure that we have the chemical formula between carbon and what? Oxygen. That is the first step. So meaning that we need to form the chemical formula for carbon and oxygen. Okay, so carbon is reacting with oxygen. Remember that on the periodic table, if you check, carbon is in group what? 4. Then any element in group 4, the valence number equals to the group number. So if carbon is in group 4, the valence number for carbon is what? 4. Then what about oxygen? Oxygen is in group 6 if you check on the periodic table, and the valence number for oxygen is equal to what? You're going to say for oxygen now, you're going to say 8 minus what? 6. Then you're going to have 2. So remember that n elements in group 5 up to group 8, for you to find the valence number, get the group number and subtract it from what? 8. So no wonder if oxygen is in group 6, I'm going to say 8 minus 6 for me to get 2. Okay, if you reach this step or stage, you're going to make sure that you do this. If there's a number that can go into 4 and 2, make sure that you use it. Okay, 2 there, 1, 2 into 4, it is 2. Then you cross multiply. 1 times carbon, it is carbon. 2 times oxygen, it is what? O2, which is now, that is what we call carbon dioxide. Okay, so that's the first step that we talked about. Make sure that you form the chemical formula. So that's carbon dioxide. Next, now we need to show the atomic structure. Okay, the atomic structure. But how are we going to show the atomic structure? Make sure that you write the electronic configuration for each atom. Okay, if you look at carbon in the periodic table, carbon, it has 12 and 6 on the periodic table, and oxygen, it has 8 and 16 on the periodic table. So we need to form the electron configuration for carbon and oxygen. So if you look at the carbon, we're going to say 2, 4. This is the electron configuration for carbon. Okay, if you look at for oxygen, we're going to say in the first cell is going to occupy 2, and the last cell is going to occupy what? 6. If you try to add this, so if you say 2 plus 6 is going to give you 8, 2 plus 4 is going to give you what? 6. Then the electron configuration is what? Correct. Whatever you're doing is correct if you're getting the same atomic number. Okay? Now, after you do this now, remember the rule that I talked about. We said we only use the last shell. So this is the last shell. Okay? That is the last shell. So I'm going to use now these 4 electrons in the last shell for carbon. Okay? Now for you to draw, make sure that you look at the chemical formula. The one with the lowest atomic number is the one that's going to be what? On the middle. Okay? So if this is now, carbon has the lowest atomic number, is the one that I'm going to draw. This is carbon. And it's going to be surrounded by how many oxygen? 2 oxygen. So it's going to be surrounded by what? How many oxygen? 2 oxygen. So let me use black for this one. 2 oxygen. Okay, and this is what? Make sure that you write the letters of atoms that you are forming the covalent bonding like that. Okay, make sure that you understand about that. Then after you do that, now this is the critical moment now that you need to understand. Again, if you look at carbon in the last shell, it has what? 4 electrons. It has to have 4 electrons. Now, these 4 electrons, for this to be stable, how many electrons does it need for carbon to be stable? Since there is 4, remember that in the second shell, for an atom to be stable, it has to have about 8 electrons. So this one I'm going to say plus what? 4. So this one requires about 4. Let me use blue for this one. So for carbon to be stable, it requires about what? 4 electrons. What about oxygen? For oxygen to be stable, requires about what? 2 electrons, like that. Okay, you write like that because 6 plus 2 is 8, 4 plus 4 is 8. So in the second shell and above, meaning that for any element to be stable, it has to obtain about 8 electrons in the last shell. Okay, but in the first shell, it has to have about 2 electrons. If you do that, now we need to proceed to another step. Another step is this one. Okay, so if carbon needs about 4 electrons, but these 4 electrons, they need to come from what? Oxygen. So make sure that you understand. So these are the foreign electrons coming to carbon. So these 4 electrons are coming from oxygen, and these 2 electrons for oxygen, they need to come from what? Carbon. Okay, so if you look at this carbon, let us look at this carbon. So this carbon, for it to be stable, it has to receive about what? 4 electrons from where? Oxygen. Now there are 2 oxygen atoms here. Okay, so we need to about what? 4 electrons here. Now there are 2 oxygen. Now these 2 oxygen, they need to share these 4 electrons. Mean that each oxygen has to give out what? 2 electrons. So this one is going to give out 2 electrons to carbon, and this has to give out 2 electrons to this carbon. So that these 4 required atom or electrons to this carbon, they are now given out like that. Okay, so these are the 4 electrons required by what? Carbon, and they are coming from oxygen. As you can see, this is the what? The shell or the last shell for oxygen. This oxygen is given 2, and this oxygen is given 2, so that now these 4 electrons are given to carbon for it to be stable. And another point is that this oxygen now needs about 2 electrons. These 2 electrons are coming from carbon. So this carbon now, since we are using cross and dot symbols, we need to make sure that this carbon also uses another symbol. So this carbon, it has to give how many? 2 electrons to this oxygen. Because if I give 2 electrons to this oxygen, and it's going to be stable. And again, this carbon has to give 2 electrons to this oxygen for it to be stable. If you look at this is oxygen, each oxygen has to receive about 2 electrons. So these are the 2 electrons needs to be received by oxygen. Okay. Then if you do this, the next important step that you need to do here is this one. The other important step is this one, is to make sure that you look at the electrons that you need to put outside that are not participating in this bonding. Okay. Now let's start with oxygen. So how many electrons am I going to put outside here? How many electrons? So you come here, okay, out of 6 electrons, because you remember that in the last shell of oxygen we need to have about 6 electrons, but out of 6 I've used about 2 electrons. The remaining is 4, because 2 plus 4 is 6. So mean that the remaining electrons that I haven't used is 4. So I'm going to put these 4 electrons outside because they are not participating in the chemical bonding. To confirm your answer, make sure that you count the number of electrons in the last shell for oxygen. They need to become 4 or 6, I mean. So you need to count 1, 2, 3, 4, 5, 6. This is the last shell for oxygen. This is correct. This is the last shell for oxygen. You do the same to the other oxygen. The other oxygen also have used about 2 electrons. Then out of 6 I've used about 2 electrons. The last now remaining is about 4. So the other 4 I need to put in form of these dots, okay? Because this is the shell for oxygen. You count again. 1, 2, 3, 4, 5, 6. This is for oxygen. Okay. Now the last important point is looking at carbon. What about carbon? Am I supposed to put anything outside? You need to check. Okay. If you look at carbon, in the last shell, we need to have 4 electrons in the last shell. So this is the one in the blue, that is for carbon. Have I used all the 4 electrons for carbon? If you look at carbon in blue, you count. This stands for carbon. 1, 2, 3, 4. Yes. So I've used all the 4 electrons in the last shell for carbon. So there's no need for me to put or to be putting electrons outside like here. There's no need for me to start putting any electron outside because I've added all the electrons for chemical bonding there. So I've used all the electrons for carbon. So there's no need for me to start putting outside. Then the other important thing is now start confirming. Start confirming. Confirming by doing what? You need to start counting. So this O circle, for carbon. So this O circle within the circle of carbon need to have about 8 electrons. So let us count. 1, 2, 3, 4. Okay, then let us count this 4, 6. I mean, this is 1, 2, 3, 4, 5, 6, 7, 8. This is within carbon, which is equal to 8. Also, this is for oxygen. It has to give us about 8. So we need to count again. 1, 2, 3, 4, 5, 6, yes, 7, 8. We are correct for oxygen. Also, for the other one, it has to give us about 8. We need to count. 1, 2, 3, 4, 5, 6, including this 7, 8, which is correct. Okay, meaning that this now molecule is stable. So by doing so, this is how you can show the chemical bonding for carbon dioxide. All right. Now, the last part that we need to talk about is this one, the characteristics. So characteristics of covalent bonding. What are the characteristics of covalent bonding? So covalent bonding, the first characteristic is that we said involves sharing of what electrons. So involves, that's the first one. If you are asked to write the characteristics of covalent bonding, we're going to say involves sharing of electrons. Okay, that's the first one. The second one is what? The second one, as you can see, on this compound, we do not have any what? Charge. If you compare to ionic bonding, we said one of the characteristics of ionic bonding is that it's going to involve what we call charges, okay? Positive and negative. But here, if you look at this diagram, we don't have the charges. So we're going to say contains no charges. Contains no charges. So there is no positive and negative charges there. Number 3, okay, do not conduct electricity. Okay, do not conduct electricity. So those are the 3 main characteristics of what? Covalent bonding. The first one is involves sharing of electrons. The second one is what? Contains no charges, do not conduct electricity, and you can also add on exists among what? Non-metals. So this is where you end from. Make sure that you study more. Until next time.